So today we are doing our final set of notes before the test, and these are going to cover equations. So if solving equations is kind of your thing, you're going to like these quite a bit. First off, just a disclaimer, let's talk about these directions in bold at the top. Solve each equation specifically for square roots. You must check your answer or answers to catch extraneous solutions. Extraneous solutions, we talked about that last semester, and we're going to see them again in a couple units. They're going to be a pretty big deal. But for now, those are extra solutions that come up when you are solving, and they don't actually work. The only way to tell that they don't work is to plug them back in and verify that they are actually wrong. I'll go ahead and be very transparent. These three problems that we're going to do that I'm going to check, they're all going to work. The ones that have extraneous solutions are actually quite complicated, so this is more so just to prepare those of you who are going on to higher level math, especially pre-cal. You will see more complicated equations that produce extraneous. So whenever you see an equation that has a square root, you should keep in mind that you should check your answer once you're done. But just to get in the habit of doing it, I am going to check these answers. And on top of that, it doesn't hurt to check answers to equations because you can actually verify that you did it correctly. So that's my whole spiel. Number 1. Square root of x plus 2 plus 4 equals 7.
Picture the mark.
So when it comes to solving equations, we've been doing this for a couple years now. I really hope you kind of developed an instinct that when you look at it, you kind of get an idea of where you should start. So looking at this equation, what feels like the correct first step?
Subtract 4 on both sides.
Yes, subtracting the 4. That's really our only option. Don't take the 2 out of the square root. That's not how we move it. And really, our main goal right now is to get that square root by itself. So that means we just need to subtract the 4. That's the only thing we can do. Subtract 4 on both sides. The 4's are going to cancel. Bring down square root of x plus 2 is equal to 7 minus 4, which is 3. I'm going to make a quick note here. This is going to be kind of a rule that we follow in most of these problems. Get the radical by itself first. That will be priority number 1 on all of these problems. From here, we're going to solve. Square root of x plus 2. We actually had this the last unit. What's the opposite of the square root?
Cube. Squared.
Square, yes.
Versus cube now.
Squaring. Squaring and square rooting are opposites. They'll cancel each other out. So we're left with x plus 2 is equal to, and I almost forgot, slipped up there, both sides, square on both sides. 3 squared gives me 9. And then from here, we just need to get the x by itself, so we'll move the 2. Minus 2 on both sides. 2's cancel. X is 7. Reminder, square root problems have to be checked. And let's talk about that for a moment. What kinds of numbers are not allowed under a square root?
Negative numbers.
Negatives. So that's why we have to check them. If we get an answer that turns this square root into a negative, that's going to be an issue. So that's why we have to check it. Let's check over here real quick. And reminder, I'm only going to do this on the first 3 problems, so just bear with me when I do this. We are checking our solution, which is x equals 7. Close that, please. We're going to plug it into our original equation. Square root of x plus 7 2, I don't know where I got 7 from, 2 plus 4 is equal to 7. So the x is going to get replaced by 7. Bring down everything else. Now I want to emphasize what we're doing here because I see a lot of creative ways to go about this when I grade the test. And a lot of those ways lead to mistakes, so I kind of want to avoid that. This really is a question we're answering. Does the left side equal 7? When I figure out what all of this gives me, will that end result be a 7? That's what we're trying to figure out. So don't move things back and forth. You can do that, but I'm avoiding that just because of mistakes there as well. So that's just me. But don't move things around. That's my biggest one. Students do it, and sometimes it goes well, and sometimes it doesn't. Again, I'm trying to avoid a mistake from happening. So just leave everything where it's at and just condense it until you get one number. We follow order of operations here when we do this. Reminder, your order of operations are PEMDAS. Now this one, the P kind of has a weird application. The square root technically falls under that umbrella term of parentheses, more so grouping symbols. So we need to get what's under the square root first before we can do anything else. So let's do the 7 plus 2. That's going to give me 9. The square root is still there. Don't drop it yet. Plus 4 maybe equals 7. Now we can take the square root of 9. We know that that's just 3. Plus 4 equals 7. Again, hopefully at this point you can recognize that this is going to be true. 3 plus 4 is 7. So we're going to get 7 equals 7, meaning it worked. This is our correct answer. Yes?
What if you did minus 4 on each side?
That's what I was saying.
Okay.
You can do that. That will get you to the right answer, but sometimes students don't do it correctly.
Okay.
So that's why I just say condense both sides, make sure they're equal.
Okay.
That's just me. And that's all. X is 7. Any other questions on number 1? Number 2. Square root of x plus 1 equals the square root of x minus 2x minus 7. Now normally our goal would be to get the radicals by themselves, but that's already been presented to us like that, so we're good there. The first thing we'll do is get rid of the square roots on both sides. So we square both sides. And these will actually cancel on both sides. So no more squares. We just have x plus 1 equals to x minus 7. When I have two x terms, I always like to move the smallest one if I can. So I'm going to subtract x on both sides. Bring down the 1. 1 equals 2x minus, reminder, this is just a 1x. So that'll give us 1x minus 7. Now we need to move the negative 7, so we're going to add 7 to both sides. 1 plus 7 on the left side equals 8. On the right side, 1x, the 1 is unnecessary. I'm going to drop it and just say x equals 8. And then we need to check. We're checking our solution, x equals 8. Plug it into the original equation, which was x plus 1, square root of x plus 1, equals the square root of 2x minus 7. Plug the 8 into both x's. Bring everything else down. And again, this is a question we're answering. Does the left side match the right side? So we'll condense both of those down and make sure that they are the same. On the left side, 8 plus 1, that just becomes 9. Equals on the right side, let's do the 2 times 8 first. That's going to give us 16. Still under the square root, minus 7. Now you can turn that square root of 9 into a 3 in the next step, but that's actually unnecessary because as long as you get the square root of 9 on the right side, then you're good. So I'm actually going to leave it that way. Square root of 9 equals, and then 16 minus 7 is indeed positive 9. So we get the square root of 9 equals the square root of 9. That's good enough. Same thing left and right side. We can say that that worked. X is 8. Questions on number 2? Number 3. 3x plus 1 to the 1/2 minus 6 equals 4. First off, some of you will recognize that 1/2 power is the same thing as a square root. So we're going to treat it just as such. We need to get it by itself first. So move the 6. It's negative. I will add 6 to both sides. 6's cancel. I have 3x plus 1 to the 1/2 power equals 4 plus 6, which is 10. Getting rid of that exponent is going to be the same concept as squaring, but it's just going to look a tad different. The idea behind it is we're going to raise it to the reciprocal exponent. Reciprocal meaning you flip the fraction. So that's 2 over 1. And when I do it to the other side, 2 over 1 is just 2. So I'm going to write 2. On the left side, these cancel each other out directly, and we just have 3x plus 1 there. Equals 10 squared. 10 times 10, that's 100. And then we solve. First I got to move that 1, so we'll subtract 1 on both sides. 1's cancel. 3x is equal to 99. Lastly, that 3 is attached to the x. We'll divide to get rid of it. X is 33. And for one last time, I'm going to check. This time we are checking the solution, x equals 33. By plugging it back into our original equation, 3x plus 1 to the 1/2 minus 6 is equal to 4. Again, replace the x with 33. Bring everything else down. And again, we're basically answering a question here. Does this entire left side, when simplified to a single number, is that number 4, or is it something else? So, again, the order of operations here, PEMDAS. Start with the parentheses, what's inside the parentheses, 3 times 33 plus 1. From there, inside the parentheses, we need to do the multiplication first before adding. So, 3 times 33 comes first. And that's 99. Bring down everything else. Next step, we're still inside the parentheses. We have 99 plus 1, so we'll do that. 99 plus 1 is just 100. Bring down everything else. Next up, we have an exponent. That's the second order of operation, or second operation. So that's what we're going to do. 100 to the 1/2 power. 100 carat. Use parentheses, especially if you have the white calculator. You have to, no matter what, with the white one. 100 to the half power, if you type it in correctly, you should get a 10. Ten minus 6, at this point I think you can clearly see that this is going to work. 10 minus 6 we know is 4. And 4 does equal 4, so yes, this works. My answer is 33. Questions on number 3. When you're ready, flip it on over to the back side so I know who still needs to write this down. All right, let's move on. Have a good weekend. The back side, all 4 of these are cube roots. Now, cube roots don't discriminate. They'll take any number. They can handle positives and negatives. So we don't have to check cube roots like we do with square roots. So I'm just going to solve, and that'll be all. You're still welcome to check your answer to ensure that it's correct, but that's the only reason you would want to, just to make sure it's right. Number 4, cube root of 3n plus 2 plus 1 equals 0. First off, get the radical by itself, so I need to move the plus 1. I'll do that by subtracting 1 on both sides. Cube root of 3n plus 2 equals 0 minus 1, which is negative 1. Now we need to get rid of the cube root. What's the opposite of a cube root? You said it earlier.
What was the question?
What's the opposite of a cube root? Cubing. Just like square and square root are opposites, cube and cube root are opposites. Whatever number's in the index, if you raise it to that exponent, it will directly cancel out that root. Works every time. And we'll cube the right side as well. These cancel. We're left with 3n plus 2 on the left equals, on the right, we have negative 1 cubed. We'll have to use the caret for that one since it's bigger than 2. And it's still going to be negative 1. 2 steps to solve. 3n plus 2. First I'll move the 2. Need to subtract 2 on both sides. 2's cancel. 3n is equal to negative 1 minus 2, which is negative 3. Remove 3 from the n by dividing both sides by 3. 3's cancel. N equals negative 1. Nu, would you close your computer, please? Will you close that, please? Thank you. Questions on number 4. Number 5. I'm going to put a star on this one. Of all the equation types, this one is most certainly the most difficult. And on the test, the most missed question by far is this one right here. Let's take a closer look at it. 2 times 6x minus 3 to the 1/3 minus 4 equals 0. Now when I ask what is the first step, there are 2 answers I'm looking for. One of them is the right one and one of them is the common mistake that people make on this test. So if you happen to shout the incorrect answer, that's fine because you're not the only one thinking it. I guarantee it. What is the first step?
Plus 4.
Plus 4 is the correct first step. Now, does anyone know what the incorrect first step is, Nate?
Distribute 2.
Distribute the 2. Divide by 2, Nate, that is exactly what I want you to do. Distribute the 2. Distributing the 2 at all is wrong. It's not that we don't do it in the first step. We don't do it at all. Does anyone know why we are not allowed to distribute into this problem?
You would change the numbers.
That's not the problem. What'd you say?
I said we just change the numbers.
You would just change the numbers? Okay.
Yeah, I was just thinking.
Okay. The reason why you can't distribute into that expression here, and it all comes down to PEMDAS, has an exponent. Exponents come before multiplying, right? It's right there in the order. So if you multiply that 2 into there with that exponent still present, you are breaking order of operations, and it's wrong. So that it's against the law, exactly. So because of PEMDAS, that is not allowed. You can't distribute on these problems. So first thing we're going to do is add the 4 over, like we've said. 4's cancel. 2 times 6x minus 3 to the 1/3 power equals 4 on the right side. And our goal is to get the part in parentheses completely by itself. So as we've already pointed out, we're going to divide by 2 because some students are like, oh, here is where I distribute. No, you don't get rid of the 2 by distributing. You get rid of it by dividing. Get rid of it completely. Divide both sides by 2. 2's cancel. 6x minus 3 to the 1/3 is equal to 4 over 2. That's 2. Real quick, I'm going to take a moment here, and just as your reminder, don't distribute. This is not one of those small errors that only catches a few students. It's going to catch a lot of students. Even the students who know better, they forget. So there are going to be students who make the distribution mistake on the test. Make sure you are not one of them. That's all we can do. Next, we need to take care of that exponent. It works just like the 1/2 on the front side. We're going to flip it and raise it to its reciprocal exponent, which is 3 over 1. Both sides. On the right side, I'll just do 3. So on the left, those exponents cancel, and we just bring down the 6x minus 3 equals 2 cubed. 2 times 2 times 2 is 8. And then we solve from here. 6x minus 3, this is a minus 3. I'm going to add 3 to both sides. 3's cancel. 6x equals 11. Lastly, we need to get the 6 off of the x, so we'll divide 6 on both sides. 6's cancel. X equals, this is a fraction, can't be reduced, and it's a horrible decimal. It's a repeating decimal that needs to be rounded. For that reason, leave it alone. It's 11/6. If you get an answer like that on the test, please don't turn it into a decimal and round. That is not my preference. My preference is to leave it alone. It's fine as it is. Questions on number 5? Go ahead.
How can you check if the answer is correct with the fraction?
With the fraction?
Yeah.
So the 11/6, it would go in up here, and then I would type in the calculator, like your first step would be to be 6 times 11/6. I would type it in just like that with parentheses around the 11/6. Are you following that? If not, we could talk about it after.
No, I get it.
Okay, cool. Number 6. 2x plus 1 to the 2/3 plus 4 equals 20. With the few examples we've already done, this one's actually going to be quite easy in comparison. Again, first thing we need to do is get that parentheses with the exponent by itself. So move the plus 4. We'll subtract 4 on both sides. 4's cancel. Bring this down. 2x plus 1 to the 2/3 is equal to 20 minus 4, which is 16. Even though this is a different type of fraction for the exponent, the rule does not change. We raise it to the reciprocal. So we're going to raise both sides to the 3/2. Exponents cancel. We have 2x plus 1 on the left side equals, we need our calculator to tell us what that is, 16 to the 3 halves. 16, caret button, parentheses, especially if you're using the white calculators, 3 ABC2, and it's nice, it's just 64. And then we continue solving. 2x plus 1, I'll subtract 1 first on both sides. 1's cancel. 2x equals 64 minus 1, which is 63. Last step, 2x, we need to remove the 2, so divide both sides by 2. X equals 63 over 2, can't be reduced, that's the fraction form. Now this is actually a very nice decimal. In this case, I'd be fine with the decimal answer because you can write it down and you don't need to round it. If you're going to use a decimal, again, it needs to be unrounded. Don't change that to a 32. That changes the number completely. That's not 32, it's 31.5. So if you're going to round your decimals, use the fraction, please. Both of these answers are correct. You can put either one. This is the one time I would personally take a decimal. Personally, I would put a decimal instead of a fraction. Questions on number 6?
Really, that's what you're over.
Yes.
I just thought that.
Number 7. This is a pretty easy problem. With how small it looks, you can tell. But there are 2 ways to go about solving it, and one of them involves something new in the calculator, so that's why there's all this extra space. So I'm going to show you this problem twice, and you solve it on the test however you want of the 2 ways. So we have x plus 7 cubed equals 8. Let's go the way with what we already know. Now, that cubed, we can take that idea where we raise it to its reciprocal exponent. This is 3 over 1, as we know, so the reciprocal would be 1/3, 1 over 3. And we raise both sides to that. This is quite a simple approach, but not every student is going to look at that and go this direction with it. They'll go the other direction, which I'll show you in a moment. Exponents cancel. We have x plus 7 equals 8 to the 1/3. Again, we can use our calculator for that. 8 caret, and then again use parentheses, please. And it's just 2. X plus 7 equals 2. Subtract 7 on both sides. X is -5. So that's option 1. Let me show you the other way. So I'll rewrite the problem. X plus 7 cubed equals 8. This way is the more intuitive way that I think most of you were probably thinking about as I was explaining it. But again, you don't know how to do this in your calculator yet. Here we have a cube. The opposite of a cube is a cube root. So if I cube root both sides, cube and cube root, they cancel. X plus 7 equals how to type the cube root of 8 into the calculator. The button is the same on both calculator types, but they're in slightly different locations. Above the caret, and let me grab one that's a little less marked up. Above the caret, you see a radical. And let me see if I can clear this up a little bit. Above that radical in the index, that's an x. That x means any number can go in there. So hopefully you've located it. On the white calculator, it's the same layout, it's just up top here. So you want that above the caret. That button is the anything else kind of root. You have to tell the calculator what number goes in the index. So the first thing I'm going to type in is the 3, since it's a cube root. And then I'm going to hit second caret to get that radical symbol there where x is now represented by a 3. And then I'll type in the 8. And it's 2. The cube root of 8 is 2. So that's how you type in special types of roots other than the square root. And then, of course, solving from there isn't any different. It's still -5. So those are your two options. Now you know. You can choose whichever you want for the test. Questions on number 7?